Hi, my name is Meha Jain, and I'm an assistant professor in the School of Natural Resources and Environment. And what my research broadly looks at are issues of sustainable food systems and thinking about ways that we can enhance production over the upcoming decades in a sustainable way. And one of the regions that my group really focuses on is India. And one reason we're really interested in working in this region is that it's currently one of the heaviest users of groundwater worldwide. Over 40% of agricultural production depends on groundwater for food security. But at the same time, groundwater levels are becoming rapidly depleted. So this is a map just showing overall groundwater risk, and you can see that many regions are red, which are showing that they're overexploited. And this is a problem that almost everyone is recognizing in India, all the way from farmers to policymakers. So one thing that the government's trying to do to find an alternate solution or a way to make sure that we can have enough production moving forward despite groundwater decline is they're creating canal networks as an alternate form of irrigation in many of these regions. But when you speak to farmers on the ground, they say that canal irrigation is unreliable. It can do well in years with really high rainfall, but doesn't do well in years with low rainfall when you mostly need irrigation. So what my colleagues and I wanted to do is we wanted to understand the relative influence of groundwater versus canal irrigation for agricultural production in India to see whether switching over to canals would be a viable source of irrigation moving forward. So to date, most studies that have looked at agricultural production issues in India have done so using district-level census statistics. And this is because this is a readily available resource that's provided by the government for decades and decades of data. The downside of using these sorts of data sets to understand issues related to irrigation is that there's a lot of heterogeneity within a given district. So this map is just showing district boundaries in black lines. And within a given district, you'll have some villages using groundwater, some villages using canal. And if you do an analysis at this scale, it's most likely going to mute the relative effect of these two different factors. So what my colleagues and I did was we used satellite imagery to produce high-resolution maps of cropped area, which is a measure of crop production on the ground. Specifically, we used MODIS satellite data. I'm not going to get into the details of how we did this right now, but I would be happy to answer questions during the break or during the discussion section. So using these satellite data, we produced data sets at a 1 by 1 kilometer resolution for every winter season from 2000 to 2015. And we linked these with village-level irrigation data that we had for every single village in India. Now we can get a much more precise estimate of how do villages that have groundwater compare to villages with canal. Specifically, we ran a suite of different regressions. Generally, this was the formula that it took. So we predicted winter cropped area based on different irrigation type. And then to get at this question of how sensitive is this irrigation to rainfall variability, we interacted irrigation type with rainfall. So here are some of our main results. We find that, so this is a parameter estimate plot where the dots are representing the coefficients of each parameter in the regression. And if they're marked as red, they're significant. So what we're finding here is that deep well irrigation, so this is the groundwater that's coming from the deepest depths in most of these regions that were red and overexploited, are associated with the greatest percent of cropped area, so they're associated with the most production. When we look at this question of sensitivity, so this is the interaction between irrigation type and rainfall, we find that these deep wells are also the least sensitive to rainfall variability through time. So these two regressions that I just showed you, they're results for all of India. And you could imagine that there might be some spatial variability based on a given state and how effective their canal irrigation is. So we redid these analyses at the state scale. And this is just a map summarizing the results. In blue are states where groundwater is outperforming canals, both in terms of extent of cropped area and sensitivity to rainfall. And you can see that the regions that are most overexploited from groundwater, so Northwest India and also South India, they're the regions where groundwater is really outperforming canals. So in conclusion, we find that groundwater irrigation is associated with increased winter cropped area and reduced sensitivity to rainfall. And this effect is largest in the areas that are facing the greatest levels of groundwater depletion. So this suggests that in terms of a policy solution moving forward, We need to identify ways to use groundwater more efficiently, particularly maybe using things like drip irrigation or switching to more less water-intensive crops. Or we need to improve the efficacy of current canal systems. Thanks.